Okay guys, in this video I'm going to continue with a few more examples on how you can solve polynomial equations. To begin with, always keep in mind guys that your polynomial should be set equal to 0 and be written in standard form. Then I would also just keep an eye on my degree, which in this example is 3. That means I should expect to get 3 total solutions if I were to count all repeated and imaginary type of solutions. Now if I could try to factor this guy, but even though it's got 4 terms, you can't always group, and you can kind of tell there is no GCF you can pull out of a 33 and a 65, so you're kind of stuck. There is no factoring this one to solve. So that means we're going to use our graphing calculator and plug this in and see if we can get solutions from our graphing calculator. So that's what I'm going to do next. I'm going to go to my graphing calculator and type in the following polynomial. If I go to y equals, and you type in the equation, I think I already have it in there actually, x cubed minus 9x squared plus 33x minus 65. Once you have that in there, remember, I like to go to zoom 6. That's your standard window. And you get this kind of goofy picture. Now, keep in mind, we're only getting a snapshot of the entire polynomial, but all we really care about is what's going on around the x-axis. And it appears, if you count the tick marks, it looks like I have a cut at x equals 5 to me. Now, if it's a cut, remember there's only one solution there. So let's see if I do in fact have a solution. I'm going to hit the trace button, and then I'm going to type 5 in my calculator and hit enter, and I do get a y value as 0 when I plug in 5 for x. That means 5 is a 0 of this polynomial. Now it doesn't appear to intersect anywhere else, and so we have one solution as 5. The other 2, if I don't see them intersecting the x-axis, must be imaginary. And I do want you to find those imaginary solutions. So this is what we're going to do. We're going to go back to do some math here. I'm going to resume. And let's see if I can go back to my original problem. Here we go. That worked. I'm actually surprised. So if I plug a 3 in, or no, it wasn't 3, it was a solution, right? We had like 5 was a 0. If I synthetic divide out my 5 for my polynomial, the coefficients are 1, negative 9, 33, and then negative 65, right? Let's see what happens. I drop down, well actually we should know we get a 0 here if I do this right, so hopefully I don't make a mistake. If I drop down the 1 and I multiply by 5, I get 5. When I add, I get negative 4. If I multiply that, I get negative 20. If I add that, that's what, 13. If you do 13 times 5, that is 65. And when you add, you get your 0, so that's great. That's supposed to be a check mark. So this is the remaining polynomial that has my other two zeros. It's 1x squared minus 4x plus 13. I just have to find when that guy equals 0. I'm going to use the quadratic formula. So it's going to be the opposite of the b value plus or minus the square root of that b value squared minus 4 times the a value times the c value. All of that needs to be divided by 2 times the a value, 1. So let's simplify. Minus negative 4 is really positive 4, plus or minus the square root of negative 4 squared is positive 16. Negative 4 times 1 times 13 is really going to be just negative, let's see, that would be 4 times 10 is 40, and 4 times 3 is 12. That would be minus 52 if I add that together. And that's all over 2. 16 minus 52, that's going to be, what, negative 42, 36. I think that's negative 36. So I have 4 plus or minus the square root of negative 36, all of that over 2. Now, I have a square root of a negative. I'm going to poke an I out. So it's 4 plus or minus I square root 36 over 2. If I continue here, let me move up a little bit, I'm going to have 4, oops, 4 plus or minus, the square root of 36 is 6, so it's plus or minus 6i all over 2. I can divide 4 by 2. I can also divide 6i by 2, giving me a final answer of 2 plus or minus 3i. Now you might think that's just one solution, but remember that plus or minus really means there's two answers there, right? So in all, if I answer the question, these are my zeros. I have 5 as an answer, then 2 plus 3i is one imaginary, and 2 minus 3i. Those are all three solutions, one real, and these two guys, they're imaginary. Let's see if I can do one more example with you guys. Actually, let's go to this page. Okay, let's make this part B. This is a good one. Let's do 7x to the fourth minus 38x cubes plus 64x squared minus 42x plus 9. Ooh, this is a nice one. Nice and long. We got 1, 2, 3, 4, 5 terms. Forget about factoring, guys. We've never really learned how to factor this, unless there was a GCF, which there's not. So that's out the window. What I am going to do is plug this long polynomial into my calculator and hopefully get all 4 solutions. That's kind of what I'm hoping for. Since my degree is 4, right? We should get 4 solutions. Let me see if I can go back to where my calculator is. Hopefully, oh, let's see. There it is. And let's type this in here. So we go to y equals, and we have to type in 7x to the fourth. Let me clear this old one out. So 7x raised to the fourth. You're going to probably beat me to this. Minus 38x cubed. Oops. Minus 38x to the third. And then it's going to be plus 64x squared, plus 64x squared, minus 42x, minus 42x, and then plus 9. So plus 9. Okay. Appears to be in there correctly. Let me go zoom. 6. And what do we see? Ooh, very, very interesting. Now, here is a great example of where it's kind of hard to see what's going on at the x-axis around 1. So this is actually quite a good problem to do along with me. Now, you'll notice, guys, let me kind of draw on here for a second. All of my action on this graph on the x-axis is occurring in this little small spot. Like really, I only care about like the lowest of x equals 0, and maybe at the most, what is that, like 1, 2, 3, 4, like maybe an x value of like 4. All the good stuff happens right in here between 0 and 4. I don't need to see what's going on here or here. So you can actually adjust your window to look at just from 0 to 4. So what I'm going to suggest you do, guys, is if you go, let me go back to the window, hit the window button. I'm going to change my x minimum value. Instead of going all the way to negative 10, I'm just going to say, hey, go to 0, and my x max of 4. So I'm only going to look at what's happening on the graph from 0 to 4, and I'm going to leave everything else the same, and let's see what happens. Hit the graph button. Ooh, this is a pretty good picture. Now, it's still maybe not super clear what's happening here, but it looks like it might be some kind of like a kiss and go at 1 maybe, and then it looks like it might hit at 3. Let's trace and just verify. It looks like for sure at 3. If I try 3, let's see. That's great. 3 I'm going to write down. 3 is 1, 0. There's a cut there. So one solution is 3. Let's see what happens at 1. 1 is also a 0. Now to me it looks like 1 has a kiss, not a kiss and go. And if you look really, really, really super closely, it does appear, let me see if I can draw on here, it does appear that the graph goes down underneath the x-axis. Right here you can see the graph, and then it goes up, kisses, and then goes back down. So it looks like there's also a solution between 0 and 1, and I don't want to like spend my time guessing what that is. So what I'm going to do is I wrote down that 3 is a solution, right? Over here there was a solution at 3. That's a cut, so there's only one 3 there. But over here this is a kiss, not a kiss and go. This is just a kiss at x equals 1. Remember, if there's a kiss, there's an even number of solutions. So I know for sure there's at least 2 1s there. There's a 1 and a 1, and I got my 3. That would be 3 out of the 4 solutions, actually. This one over here being the 4th. So let's go back to the drawing board. Let's see if I can go back to my drawing board. Please let me do it. Let's see if I can do it. Resume back. Bear with me, guys. Yes, of course. Now it's not. It didn't do what I wanted to do. That's okay. Let me go back to my whiteboard. I apologize for the little glitch. But if I go back to the whiteboard, remember I had one solution at x equals 3, and then I had 2 solutions at 1. Remember, that was where that kiss was. I know there's an even number of repeats whenever it kisses. So what I'm going to do is I'm going to synthetic divide out each of those to try to figure out what that last solution is. So first I'm going to synthetic divide out the 3, and it really doesn't matter which one you do first or second or third. The coefficients of the polynomial, if you look back, were 7, then negative 38, and then 64, and then negative 42, and then 9. Okay, so I draw my line. Remember, I'm expecting a 0. If I drop down the 7, I get 7. If I multiply, I get 21. If you add negative 38 and 21, we get negative 17. 3 times negative 17, that's going to be, negative 51. If you add 64 minus 51, that's what, 13. 3 times 13 is 39. If you add those, you get negative 3. If you multiply, you get negative 9. If you add, you get 0. Awesome. Now, I'm going to synthetic divide out a 1 right away. And I'm just going to build on these coefficients. I don't need to use that one. I'm not going to use the remainder. But I'm going to drop down the 7. And I multiply 1 and 7, I get 7. If I add, I get negative 10. If I multiply, I get negative 10. If I add, I get 3. If I multiply, I get 3. When I add these, I get my 0. That's great. Now I'm going to synthetic divide out a 1 once more. Remember, there was 2 1s because of the kiss. And I'm just going to use these coefficients. If I drop down the 7, I get 7. If I multiply, I get 7. If I add, I get negative 3. If I multiply, I get negative 3. If I add, I get 0. Okay, awesome. This is just a linear equation. This is the constant, this is the x coefficient. So I have to solve when does 7x minus 3 equals 0? Well, great news. Add 3, get 7x equals 3. And if I divide, I get 3/7. That decimal where the graph cut through the x-axis is 3/7. So in all, my solutions are as follows. I have 3/7. I had 1 and 1, and then I had a 3. Pretty cool. Thanks for watching, guys. Hope it helped.